I wanted to go a little further with this one lab though before we go on with some other commands. We looked at router 3 with show IPv6 route OSPF, and we didn't see anything we didn't expect to because both routes that router 3 is connected to, it is connected to. So OSPF did not discover the routes. However, in this point in our configuration, router 1 should see the segment connecting routers 2 and 3, and router 2 should see the segment connecting routers 1 and 3 as OSPF routes. So let's go back to the equipment and make sure that it does and that we have our connectivity. And there it is. On router 1, I just ran show IPv6 route OSPF, and it shows the link connecting routers 2 and 3. So let's ping router 2. And then finally 2. And we've got our connectivity there. We'll go over to router 2 now, run show IPv6 route OSPF. And there's our link connecting routers 1 and 3. And we can ping 2001, 1111, 2222, 131. And there we go. So we have our routes on routers 1 and 2 as we would expect. We've got our connectivity, and everything is just gold there. So let's skip ahead in the screens. We're not only skipping ahead, but going way ahead because most of this we saw, but we didn't see this. So this is where I wanted to pick up was with some similarities and differences between OSPF v3 and v2. And really, when you keep your version 2 rules in mind when you're working with OSPF version 3, you're gold. And one of them, the design rules are the same. Each area has to contain an interface on a router that also has a physical or logical connection to the backbone area. And so our design is perfectly legal because area 23 is the only non-backbone area, and it contains an interface on a router that is also connected to area 0, that being router 3. Plenty of other similarities. Got some on the board here for you. Obviously, they have to agree on hello and dead timers, as you can see here from the screen. On serial 01 on router 1, I just changed the hello interval just slightly, but just slightly is enough. And you can see the adjacency came crashing down even before I could run show IPv6 OSPF neighbor again. Got interrupted there. And then when I removed that hello interval command, it of course went back to the default, and seconds later the adjacency came right back up. The overall OSPF neighbor discovery process via hello packets is exactly the same. Both versions are going to use maximum paths to control how many paths OSPF can use for equal cost load balancing. Both versions use our old friend default information originate. And I know you're tired of this command and hearing about it, but they're big on it. What happens again with default information originate? That allows the OSPF speaking router to advertise a default route if it has one in its routing table. But on occasions you may not have that, but you still want to advertise it, say to some stub routers. So what you could do is run default information originate always advertise default route. And in this case, iOS help means when it says always, it means always, even if you don't have one yourself. So an important command there, good review. Again, our DR, BDR elections, they're carried out in the same fashion between the two versions. A router that detects a network change is going to let the DR and the BDR of that segment know directly, and then it's the DR's role to flood news of that change throughout the segment. That's why we don't have DR BDRs on point-to-point links, because when one router tells the other router on the segment about the network change, there's no one else to tell on that segment. The adjacency states remain the same, and they can be viewed as we saw with show IPv6 OSPF neighbor. The terms ABR and ASBR mean the same thing in both versions, and in this network, R3 right now is an area border router, an ABR. And we ran show IPv6 OSPF on that router, and we saw in the second line under the routing process, and it's going to name the RID as well, it is an area border router. And we looked at all of that information. Now, an ASBR, just as a quick reminder, it's an OSPF router that performs route redistribution into OSPF. We saw a demo of that in version 2. I'm going to give you one here or two. You're not going to have to configure ASBRs and route redistribution in the CCNA exam, but I want you to see what's going on there and exactly what happens. More similarities. You can change version 3 costs with the nearly same commands we used in version 2, and we went over all three of these. You can change the interface cost directly with IPv6 OSPF cost. You can use the bandwidth interface level command. or you can use the auto cost reference bandwidth command and keep it uniform throughout your network. So saith Cisco and so saith Chris. You really need to do that. Show IP OSPF interface. We ran this one live as well. Let me bring that back up. Let's hop over to router 2. IPV6. Ha! If you run this command by itself, and by that I mean you do not specify an interface at the end of the command, you just run show IPv6 OSPF interface, it's going to give you this information for every interface on the router running OSPF. So right now, of course, we're only seeing it for one, but let's say that you had, I don't know, 4 serial interfaces and 2 Ethernet interfaces and 6 loopbacks. You might not want all that information at one time. So running the interface name after interface here is usually a good idea. And again, link local address right here. Here's the area ID, the process ID. We got your RID, your network type, your cost, your state, the timers that you've got configured, when the next hello is due, and then your list of adjacencies here at the bottom and who you're suppressing those for. So a ton of great information there. Now there is a brief version, because you do get a lot of info here. There's a brief version of this command as well. Hopefully, yep, here it is. I have seen this occasionally not show up, so it may be iOS specific, but that brief command is good to know. And boy, when they say brief, they mean brief. There it is, your interface, and then your area, your cost, and your state, and how many neighbors you got, etc. I personally like to use the full command, because you just get a lot more information without getting 20 screens of it. That's always helpful. So we've got that brief command, show IP protocols. I believe we looked at with show IPv6 protocols. Yep, we did. We're not doing any redistribution interfaces you're running it on, so not much to show there on router 1 right now. And yes, you can still use passive interfaces in OSPF version 3. All you do is run the passive interface command under the router process in router config mode, and then name whatever interfaces you want to be passive. There are some differences, and there's one major one here. Potential OSPF neighbors no longer have to be on the same subnet in order to form an adjacency. Let the pigeons loose, because of course you did have to do that with the previous, OSPF 4 IP version 4. But again, with OSPF or IP version 6, potential neighbors do not have to be on the same subnet in order to form an adjacency. There are some LSA differences we're not going to go into. They're really beyond the scope of the exam. Type 3 LSAs were renamed from summary to enter area. Couldn't hurt you to know that when you're actually looking at the database. But the changes, again, are way beyond the scope of the exam. Now, that concludes our official look at OSPF for IP version 6. What I am going to do is run a quick route redistribution scenario on the next video. And you don't have to watch it if you don't want to, but I think you should. It's good stuff to know, and I'll see you on that video.